Hi, welcome to this lesson on finance, future value annuities. Let's have a look at question 5. Dan wanted to save 450,000 Rand as a deposit to buy a house on the 30th of June 2023. He deposits a fixed amount of money at the end of every month into an account earning interest of 8.35% per annum, compounded monthly. His first deposit, was made on the 31st of July 2018, and his 60th deposit on 30th of June 2023. Calculate the amount he deposited monthly. Okay, so we have our number line. So what's actually happening here? So T0, T1, T2, all the way up to, they say, the 60th deposit, so T60. And it's happening at the end of every month. And the first one he made, T1, was on the 31st of July, 2018. So the 60th payment will be the 30th of June, 2023. So we have our N being 60 months, which is good because our interest rate was given as compounded monthly. So our nominal interest rate here is going to be 0.0835 over 12. And I'm going to store that as A into my calculator. So 0.0835. Okay, if you did have a previous A value stored in from a different problem, what happens is if you do this calculation now and you go shift store A, it'll override whatever you had as A. So if I click alpha A now, you can see it gives me the new value for that interest rate that I put into A. All right, so what are we looking for? We're looking for the amount that he must deposit monthly. So we're looking for X. So in the future value formula, F equals X times 1 plus I raised to the power N minus 1 all over I. So solving for X, X is going to be equal to F times the interest rate I, all divided by the quantity 1 plus I, all raised to the power N minus 1. Okay, and we have all our variables in place, so we can put it into the calculator. All right, so the future value was 450,000 Rand. That's how much Dan wants to save after that amount of time. It's going to be times the interest rate, which we've called A in our calculator. In the denominator, 1 plus the interest rate, which is going to be alpha A, raised to the power 60 months minus 1. And I get 6,068. So 6,068.69. Okay, so Dan will need to save, or not save up, but rather deposit 6,068 Rand and 69 cents into this bank account every month for 60 months consecutively. And this will enable Dan to have the necessary 450,000 Rand saved up for the future. All right, so when we do these types of future value annuity questions, what's really important is that we are identifying all the key variables correctly. So F being the future value, how much you are saving up towards. X being the regular deposits or installments or payments that you are making to save up for that future value. I being the interest rate, noticing whether it's an effective or nominal interest rate depending on the time period given. N, your time period, again, depending on the interest rate, whether it's compounded monthly, compounded biannually, compounded quarterly, and so on. So we have to look for all these important different factors when we substitute these values into the future value formula, because those values make a very big difference when you do the calculation, and you don't want to get it wrong because you're dealing with money here in the real world, right? So there are severe consequences if we don't do these calculations correctly. All right, so this is how we would do this type of question. I'll see you in the next one.